Hey friends, today our problem is for a given positive number, in how many manner can it be represented as the sum of consecutive prime numbers? For example, we have 53. So 53 can be represented as 5 plus 7 plus 11 plus 13 plus 17. And so there is only one representation for 53, that is, so our answer will be 1. And then we have 41. So 41 is 2 plus 3 plus 5 plus 7 plus 11 plus 13, and also 11 plus 13 plus 17. So this both add up to 41. So we have two representations for 41. And let's take 20. So 7 plus 13 is equal to 20, and 3 plus 5 plus 5 plus 7 also equals to 20. But our answer for 20 will be 0, because we have to find the prime numbers which are consecutive, like after 2 we have 3, after 3 we have 5, and so on. So one prime number comes after another. Here if you observe, 7, like after 7 we have 11. So this 7 plus 13 does not fulfill our criteria. And in the similar manner, after 5 we are taking again 5, but after 5 we should have 7. So 20 does not fulfill our criteria. So as we can see, we have some sample inputs and sample outputs. So if our input is 2, our output is 1, because 2 can be only represented in one manner, that is 2 itself. So for now, like, what should be our approach for solving this problem? So what we shall do is, we'll first take all the prime numbers 2, 3, 5, 7, 11, and so on, and we'll try all different possible combinations of them and see whether they are equal to our input. So for this we'll be using two for loops. We'll first keep our one index fixed and we'll vary our other index, and then we'll for this fixed and varying index, we'll see whether the sum up to some particular point is equal to our input or not. So let us take an example of 17 and see. So 2 plus 3 plus 5 plus 7 is equal to 17. So once if our sum is equal to our given input, then we'll move our I to next and our j also to next, and then for remaining numbers we'll check whether the sums are equal to our given input or not. And if they're equal, then we'll increment our counter by 1, and if they're not equal, then we'll not increment our counter, and then finally we'll get print our count. So count will be our answer, which will be represented here. So let's move on and see some code for this. As you can see, we have included our standard libraries. So if you want to import this bool function, bool is nothing but true or false. Either you get 0 or you get 1. If you want to use true or false in your code, you need to include std bool.h. After this, we have defined the size of our array in which our prime numbers are stored, and the maximum limit of the prime number, sorry, the upper limit of the prime number. And then we have declared our total equal to 0. Total is a variable which we'll be using afterwards. So then here is our function which tells whether a given number in the input is prime or not. So this function basically does it checks for a given input. Suppose we have 17, so it will try dividing this 17 by all the prime numbers available. So if uh, if the remainder is equal to 0, here we are using the modulus function which gives remainder after dividing two numbers. So if the remainder is equal to 0, the number is not prime, because of course it is divisible by a prime, so it's not prime. And then if it is not, then we will be returning true. So then we start with our main function. We take a for loop, and then we start filling our array in for 2, 3. So you can observe we have started our for loop in 2, 3, and then so on up to uh, the upper limit. And then every time we do that, we keep on increasing our total. Since you can observe here, we had set the total to 0. So once the every time we need to increase the total, because then we'll get, otherwise we'll get segmentation fault and our code will be dumped. And then we are equating, if the number is prime, then we are equating it into the array, otherwise we are ignoring that number. After this, we'll be taking our first input, the like our input which we have to see the combinations for, and then we take a counter known as ans, basically our answer, and then we run two for loops, one starting with 0, another starting with the current position. So like, as I told you, if we have 2 3 5, so first I will be on 2, that is starting from 0, and j will be also on 2. Where I goes, we'll check our combinations from that position, and then every time we increment the counter and then equal it to prime number. Basically we are adding counter equals to 2 plus 3 plus on so on, like that, in that manner. And if our counter is equal to the given input, then we increment our answer, otherwise we not. And finally we print our answer and take the input for next one. And if our input is 0, so we are having a 0, and this is a while loop. So for computer programming, while, if the thing gets false, so it will exit out of the loop. So thank you, this is all for today.